I'm just going to wait until 5:35 to get it started. But I wanted to introduce myself again. My name is Olga. I'm a longtime tutor with Kweller Prep, and it's my pleasure to be running this webinar for you guys tonight. I know a lot of you guys are testing tomorrow, so we'll be working with state test math for the Common Core curriculum, and we're going to be covering grades 3, 4, and 5 for tonight. So if everybody in the chat can just put in the grade that they are in or their child is in, just for me to see who the group is. I'm going to try to definitely cover all grades today, but if our group is leaning one way, we can do more time in a certain grade. And I'm just waiting for people to come in still from the waiting.
Good. Olga, this is about it. Okay, and I'll let a few more kids know, but this is just about the group. Okay.
Sure, great. So we can go ahead and get started.
Yeah, you can get started right away. Go ahead.
Okay, so we're going to start with third grade for a little bit, and then we'll move into fourth and fifth, because it seems like that's where the majority of our kids are from today. So in all the grades, the state test is going to be made of some multiple choice questions and some short answer questions. So that's what we are going to be working with. These are real released exams from 2022, and this is the absolute best practice that you guys can do. Now, let's start with a multiple choice question. So Mr. Green buys 4 packages of cups. Each package has 8 cups. Which expression can be used to find the number of cups that Mr. Green buys? So anytime we do any mathematics, my sort of approach to it is always to consider strategy. So when we read a word problem like this, we are reading for keywords. So one keyword that I can see is each package. So usually when we have the word each, we're dealing with a word problem that has to do with products. Because imagine that you're purchasing one of something and it costs some amount of money, and then you're purchasing 2 of something, that amount of money then becomes doubled. Then you purchase 3 of it, it becomes tripled. So each has a very distinct relationship with cost, and very often that is a keyword for either product or quotient. So right away, just from seeing the word each, I know that most likely I'm dealing with either multiplication or division. So now in this case, he's buying 4 packages of cups. So you can imagine 4 packages, right? Here are packages, and each has 8 cups. So within each one of these is 8 cups. So which expression is going to give me the total number of cups? Exactly. Yep, you guys are getting it right. In the chat, 1 is absolutely D. So I want the kids and the parents to take a few things away from this question. One is this keyword approach, which helps magically, just preparing you for the kind of testing structure that the curriculum is based upon, and that will later help with other exams they take, other standardized exams. And the other approach is this visual approach, which is new to the Common Core curriculum from a few years ago. They became a lot more visual, and they put a lot more emphasis in visual type of learning. So I always like to teach that approach to students as well, for them to consider it sort of mathematically and visually. So there we have it. Number 1 is choice D. Now, if we take a look at number 2, they're asking us which fraction is represented by point M on the number line below. So what can you guys tell me about this number line? How many points do I have? How many pieces is that line connecting between 0 and 3? I mean 0 and 1, sorry. So here's one piece, right? Here's a second piece, and here's a third piece, right? So the gradations on this number line divided it into 3 pieces. Does that make sense? So what we can understand is that from 0 to 1, each piece is a third. So this would be a third, and then that would then be 2/3, and then that's 1 or 3/3. So when you take that approach, again, a visual approach where you see that we divide this piece into 3 equal portions, we can then see that point M is located at 2/3. So what option out of these can I definitely eliminate right away? Which option would you guys eliminate, and tell me why? So who could tell me which option I would have to eliminate? So right off the bat, I would eliminate 3/2. Why? Because this is greater than 1. So it makes no sense for point M to be greater than 1 because we can see that it's within 0 to 1. Okay, so moving on to next page. Does anybody have any questions on these first two? Okay, so moving on. So these first two so far tested number lines, fractions, simple operations, and products, which are all very, very common topics across 3rd, 4th, and 5th grade. The difference is that the level changes, but the topics kind of stay the same. Now, this next one is another one that's definitely always going to come up. They're testing us on geometry here. So this is another type of question that is very, very common and will definitely come up across the tests. So this is asking us for the area of the shape the student made. So how would you guys approach this? The big way to approach these questions is that you divide it into shapes that you know how to manage. So right now, this is 1, 2, 3, 4, 5, 6 sides. So it's a weird sort of hexagon, right? And we don't know how to find the area of this kind of hexagon. But what we would do is we would divide this like this. And now it becomes into a square and a rectangle, which we do know how to work with. So what is the area over here of this square? How do I get the area of a square? The area of a square is just side times side. And in this case, that's 5 times 5, or 25. And how about the area of this rectangle? Area of a rectangle is going to be length times width. I have my width here, right, of 3. Now this part can be a little bit tricky, right? I know that this is 5 and the whole thing was 9, which leaves me with 4 for this piece. So the area here where I'm shading is going to be 4 times 3, or 12. And now the total area of the shape, we have to combine our two sides. So we have to combine the blue to the red. So we're going to do 25 plus 12 to get us that final answer of 37. Good. So this is extremely, extremely common. They will definitely ask you for area. For the upper grades, they start asking for surface area, which is a very similar type of concept. But the big things that I want you guys to take away from this question is that you divide the big shape that they're giving you into more smaller, reasonable type of shape, a shape that you are comfortable with finding the area with or the perimeter with for, or whatever it is. Good. Anybody have any questions? Okay, so we're moving forward to the next one. We have a worker has 3 bags of pebbles to use in a garden. The mass of each bag is 9 kilograms. What did I tell you guys about each bag? About that word each. What did we learn just from the first question earlier? Come on, guys, wake up. What did I say about each? Yep, to multiply, right? So each bag is to multiply. So now we can check if that rule works. So we have 3 bags to use in a garden. Here are bags 1, 2, and 3, and each of them is 9 kilograms. This one's 9 kilograms, this one's 9 kilograms, and this one's 9 kilograms. So what is the total mass? Just like we did for the first question, we multiply. So we do 9 times 3 to get us the answer of 27. Excellent. A different way to think about it is you could just do 9 plus 9 plus 9, but the more efficient way to think about it is 9 times 3. Okay, moving on to number 9. So first, what is this expression equal to? What's 5 times 7? That's just 35, right? But do we need to know that to get this right? Plus minus, right? So we know that this is 35. Now, what do I have to do in these cases? When I see parentheses, what does that mean? Do I do parentheses first or last? What is this question testing us on? What concept? So this question is testing us on order of operations. So another really big thing that I want you guys to take away from our webinar is you have to get good at figuring out what they're testing you on, right? So from a young age, I want to teach my students to think like the test maker, because when you know what they're testing you on, you know how to get the right answer. In this question, they want you to show them that you know order of operations. So you have to prove that you know what order of operations is. So exactly, somebody's putting it in the chat. Excellent. Order of operations, the rule that we all learn is PEMDAS. So what does PEMDAS tell us? What does the P stand for in PEMDAS? Awesome. Yep, parentheses. So in all of these examples, that means before I do anything, I do what's in parentheses first. So in this choice, in choice A, I do what's in parentheses first. So 4 plus 3 is 7. And then I do 5 plus 7. So this one will equal 12. And is that equivalent to this? Nope. So we can cross it out. Goodbye. Right? We don't need this. How about the next one? What's inside the parentheses? 4 times 3. 4 times 3 gives me 12. Then I multiply that by 5. What does that give me? 60. Good. And is that equivalent to this? Nope. So goodbye. We throw this out as well. Now, what happens next? What happens in the next choice? What's 5 plus 3? 8. And what's 5 plus 4? 9. We have two parentheses now, so we do each operation within our parentheses first, following the rule of PEMDAS, and then in the middle, it tells us multiply them out. So that equals 72. Is that the same thing? Nope. So we get rid of this as well. And then finally, by process of elimination, I know that most likely this is my answer, but let's just complete it to make sure. 5 times 3 is 15, and 5 times 4 is 20. And when we add those up, we get 35, which does match our answer. That is equivalent, and that's it. We're done. We got to the right answer. Now, just to complete our review and our notes, PEMDAS, right? We said P is for parentheses, and somebody put it in the chat. E is for exponent. M is for multiply. D is for divide. A is to add. And then finally, S is to subtract. But an important point that I want you guys to think of is that parentheses is first, definitely, right? No questions asked. Exponents is second, definitely, no questions asked. For multiplication and division, it's whatever comes first, left to right. So sometimes division can go before multiplication. These are more left to right. And the same idea for addition, subtraction. So together these come third, and together these come fourth. Just to give you a little bit of nuance, so you understand PEMDAS fully and wholly. All right, guys, awesome. Anybody have any questions on this page? Great. Okay, so we're gonna keep going along. So now we have Zach earns the same amount of money each week doing yard work. If he earns $36 at the end of 4 weeks, how much money does he earn each week? So you guys see, I'm not making this up. We have a very similar type of question. We're using each again in the word problem. So it's telling me in my head, I know which operations each tests. I know that this is either multiplication or it's division. So this seems that at the end of 4 weeks, he made $36. So in 4 weeks, he made $36. And the question is, well, in 1 week, how much money does he make each week? So now looking at all of these options, which one would you guys eliminate right away? Which one does not make sense? Right? It can't be 144, right? That makes no sense because he makes $36 in 4 weeks. So how could he make a number that's greater than that in just 1 week, right? So C and D goes to the garbage can right away. We don't even consider that. And even though it's silly to sort of tell you guys what's not the right answer, it's really important as a test taking strategy that you start training your brain to do that because these are multiple choice exams. So without any calculations, I can say that 40 and 144 are just impossible. But now we think about 32. Is that likely if in a total of 4 weeks he makes $36? Is it possible that evenly in 1 week that would just be 32? There's no way that's possible. That's too close to 36. So without doing any math, I can comfortably say that the answer here is choice A. And I want you guys to kind of get good at that kind of comfortability. Of course, if we want to prove it, all we do is 36 divided by 4, and we get to the right answer of 9. Now, the next one is just an arithmetic question. So this one's pretty easy. What's 7 times 70? 490, right? Simple. For this one, I would just say be really, really careful. Read carefully, right? That's the biggest advice that I can give you guys for any test, but especially these state tests because you guys have a lot of time. They're very long, so you can give yourself full leeway to think, read carefully, make triple, quadruple check that you're doing the right thing. So very often they put a trick answer as choice A. So if you were reading this and rushing through this very quickly, you could think that, oh, 7 times 7 is 49. But be careful, it's 7 times 70. That's why there is this extra 0 here that makes it the correct answer. Okay, next one, we have a student draws a rectangle on a sheet of paper. So my recommendation when you're doing a question like this and they tell you that somebody's drawing something, you also draw it. So let's draw a rectangle on our sheet of paper, right? Here's our rectangle. Then they label 2 of the sides as 1 unit and 2 other sides as 2 units, right? So we're just going to match them, right? 1, 1, 2, and 2. And now they want the area. So at this point, before we even finished reading the question, we already have our shape in front of us. So how do we now find the area of this? I gave you guys the area of a rectangle before. We know that area is just length multiplied by width. So in this case, it's just 2 times 1, which is going to be 2, right? There's our answer, choice A. So just for fun, who can tell me the perimeter of this shape? Excellent, right? 6. So just to review, perimeter means you add up all the sides. So it's length plus width plus width. So you add up all the sides. And in this case, it would be 2 plus 2 plus 1 plus 1. Like you guys already correctly said in the chat, 6 would be our perimeter. And again, this goes back to read carefully, circle what they want, because they could have asked the same exact question with perimeter. And of course, they put that as an option. So just be sure that you're answering the question that they want you to answer. Okay, moving on to the next one. So this is already getting into a little bit of pre-algebra. So they want you to fill in the blank. Which option makes this true? So 48 divided by what will give you 8? So absolutely, you can just plug in and see, well, 48 divided by 6, that absolutely works. That gives you 8. Again, looking at the options, definitely cannot be 56, right? When we take a number and we divide it by a number greater than that original number, we end up with a decimal, a fraction, something less than 1. So right away, just looking at this without even like thinking or activating my brain to calculate anything, I know D is not the answer, right? So there's no way, even if you guys are really, really stuck on a question, you use these kinds of techniques and you get rid of the answers that are just impossible. And it gives you a lot more leeway to kind of make a more educated guess rather than just a random guess. Okay, so here we have a fraction. What fraction is this model representing? Who can tell me which fraction? 2/4, excellent. And what does 2/4 simplify to? 1/2, great. So now all we have to do is we have to find a fraction model that represents the same exact thing. So we're going to go through all of these. You can kind of see visually like which one looks like kind of half is shaded. So like right away, I can kind of tell that A has too many things shaded. This is way greater than a half. And C has too little things shaded. Right away, I'm gravitating towards choice D. And then we can just double check. In choice D, we have 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 2, 3, 4 shaded. So we have 4 out of 8. Now, just for some extra practice, what fraction is choice B representing? Yep, and when you answer the question, try your best, yeah, just to simplify it. Yep, 1/3. Good. What about choice C? Choice C is 1/4, right? 2/8, which then goes to 1/4. And lastly, what about choice A? Excellent, 2/3, right? 4/6, which then simplifies to 2/3. Great job, guys. Okay, let's keep powering through. We're almost through with the multiple choice, and then we'll switch to short answers. Okay, so we have Greg walked 1 mile from his home to the store. After walking 2/6 mile, he stopped to smell a flower. After walking another 3/6 of a mile, he stopped to tie his shoe. Which number line shows this correctly? Okay, so what do you notice? In every single number line, we have 1, 2, 3, 4, 5, 6 little pieces, right? So at piece 2 out of 6, we expect the flower. So is this the right answer? Where's the flower? The flower here is at 1/6, so it cannot be A. That's it. I don't waste my time checking the shoe. It doesn't matter. Same thing for choice D, right? We're at 1/6 for the flower, which cannot be correct. So we eliminate that as well. So now we're picking between B and C. Which one's the right answer and who can tell me why? In both cases, here the flower is at 2/6, right? Then they tell you that they walked 3/6 more miles, right? So 1, 2, 3, right? Versus here, it's 1, 2, 3. So what's the difference? Well, here we have 1, 2, 3, 4, 5, 6, 7, 8. So they almost tricked me. So this is out of 8s, right? So cannot be C either. And then the best answer is choice B. And be really, really careful not to fall for that trick because I almost fell for it, right? Because it looks like it's in the right position, but it's not because this is out of 8, not out of 6. So B is the correct answer. Good. Okay, how about the next one? Which rectangle is cut into 4 equal pieces? This one is really just a visual question. Absolutely, the answer is B. We can see that it cuts this side in half, and this cuts the width in half, which creates 4 equal pieces, which is not the case for any of them, for any of the other rectangles. Next, we have a pet store has 4 fish tanks of the same size. A worker puts 10 liters of water in each fish tank. What is the total number of liters of water the worker puts in all of these fish tanks? So I think this is the fourth question where we see the same thing. We have the word each, right? Each. I can't emphasize this to you guys enough. So even if you know nothing about math, if you're horrible at math, if you really, really struggle, this word each tells you what to do. It tells you that we have to multiply or divide. In this case, we are multiplying. So 4 fish tanks multiplied by 10 liters in each tank gives us a total of 40 liters that he puts in all of the tanks combined. So again, looking at the option, I know automatically like it doesn't make sense for my answer to be 4, right? Because I put 10 liters in one tank. So how could my total be 4? Or how could my total be 6, right? These are the ones, the nonsense answers, the ones that we can eliminate right away without even thinking about it. Okay, good. Any questions? Okay, next one. Which fraction is less than 1/4? Great, absolutely. 1/6, really good. So we can obviously see that 2/4 and 4/4 are equal. So there's a few rules I want to review with you guys. When the denominator is the same, to figure out which one is greater or less, we just compare the numerators. So let's write that down. When denominator is the same, just compare numerators for size. Number 2 is when the numerator is the same, it kind of flips, right? So when the numerator is the same, bigger denominator means smaller number overall. And then obviously the opposite is true. Smaller denominator means bigger number overall, right? So in this case, our numerators are the same. So because 1/6 is the smaller denominator, that means that it is a 6 is the bigger denominator, excuse me. So that means that it's a smaller number overall. So that's why our answer is 1/6 versus 1/3 is the smaller denominator. That means it's the bigger number overall. So this one is bigger. And then the thing that I always teach all my students that helps later on when you guys are going to be applying to go to specialized high school and etc. is try to start memorizing fraction and decimal equivalents. So we know that 1/4 is 0.25. So you should start thinking about the fact that 1/3 is 0.33. You should start thinking about that 2/4 is just 1/2, and that's 0.5. So not so important for the state test, but just to start putting a little seed in your head, and that way when you hear it enough times, it's not something that you have to learn, you'll just remember it. And once you know these decimal equivalents, it becomes a lot easier to order the numbers from smaller to greater. Okay, so moving on to the next one, we have Micah has 35 gumballs. He gives all of them to 7 friends. Each friend gets the same number of gumballs. Which expression? So I know already, right? We have each. It's not going to be subtraction. It's not going to be addition, right? I'm choosing between division and multiplication. So what are we doing in this case? We have our total, and we are splitting that total into 7. So we're dividing that total into 7. So this one is division. When they ask you for the total and you see the word each, in those situations, that's likely multiplication. All right, how are we feeling? Is everybody good? Anybody has any questions? Okay, I'm going to skip forward a little bit to the 3rd grade. Short answers. We'll maybe do 1 page, and then I want to get to the explanation ones, not just the answers. So maybe let's do 1 page of this and then 1 page of the explanations. And then we're going to move on to 4th grade, okay? Okay, so with the short answers, our strategy changes a little bit because we don't have options, right? We don't have a situation where I can eliminate things anymore. So instead, we now have to actually solve the question fully. So we have 3 classes are on a field trip at the zoo. The number of students in each class is listed below. Class A has 24, Class B has 23, and Class C has 25. At the zoo, all the students are placed into 8 equal groups. How many students are in each group? So how are we tackling this? What would you guys do? This is what we call a 2-step question. What would we do here? Add them all up. Yep, that's going to be our first step. So we're going to have 24 plus 23 plus 25. And that's going to give me 72. And then we divide them. Perfect. And then you show 72 divided by 8 tells me that there's 9 students in a class. And then you rewrite your answer on the line. Very important. They will not give you credit if you do not put your final answer on the line that they provided. So that's just as important as everything else that you do. So let's talk about keywords for a second. All the students or total, those are kind of keywords for sum. That's how we knew to add everything up. And then 8 equal groups is our keyword for division. So in the words that they use, they give you sort of hints for the operations that you have to do. So that's how we knew to add and then to divide. And then in terms of showing your work, what gets full credit is exactly this. Just show your work. Show that you're adding them and then show that you divided. Even if you can do the whole thing in your head, put it down to paper, like the steps that you're taking, in order for them to give you that full credit. Excellent. So let's tackle the next one. We have a figure shown, and it says 1 more row of 6 unit squares is added to the figure. What is the total area of the new figure after the unit squares are added? Okay, so what does a row mean? So there's many different ways that you guys can approach this question. Row goes horizontally, so this is a row. So each row here has 6 units. So one approach is you can find the area right now. So you could say 1, 2, 3, 4 by 6. And you can say 4 by 6 is 24, and I'm adding one more row of 6. So 24 plus 6 gives me 30. You can do it that way, or you can redraw the shape, right? And we have 1, 2, 3, 4. 1, 2, 3, 4, 5. And then you can add a sixth one. That would absolutely count to showing your work and show that there are 30 total. That's completely fine. For my visual learners that like drawing pictures, that is absolutely appropriate and will give you full credit. So any way that you think of doing it, whether you want to show your work numerically, whether you want to just do 6 times 5 equals a total of 30, all of these 3 different ways would give you full credit. But you must show something, right? You can't just put 30 as the answer choice. You would lose a point. You must show your work, whichever way that you reach your answer. Okay, and we'll do these 2 more, and then we'll go ahead and we'll switch to the 4th grade packet. So we have the manager at a movie theater needs to order 267 new seats. If the seats are sold only in groups of 10, what is the least number of seats that the manager should order? So how are we approaching this one? So it has to be sold in groups of 10. So that means that the number needs to be divisible by 10. Does that make sense? So what number is close to 267 that is divisible by 10, and that will be enough for at least 267 seats, 267 movie seats? What number fills those requirements? So again, the way that I would think about this, and I would say seats need to be purchased in groups of 10. Therefore, 267 seats rounds to 270, which is divisible by 10. 270 divided by 10 equals 27 groups of seats. Two 60 is also divisible by 10, but wouldn't be enough. Right? So essentially what these are testing you for is valid thought process, valid explanation. You have to use words like therefore or because. Those show understanding and those show that you're relating different ideas together. Any explanation is good enough. It doesn't have to be exactly what I'm writing, but there have to be similar ideas. You have to show them that you're thinking through the question. You're thinking that, well, 267, 270 is more than enough seats, but it has to be 270 because I can only buy seats in groups of 10. And my other option, if I don't buy 27 groups of seat, 26 groups of seat would be too little. And they want the smallest number of seats. So it can't be 26 because that won't fit. So 27 is the smallest. You could buy 28, right? That would be 280, more than enough for everybody. But the question isn't what's a number of seats that could work, it's what's the least number of seats that could work. So just make sure that you are addressing the question in full, that you're using words like therefore, because that show connection and relationships, and that you're fully answering their question and explaining. Okay, how about this one? So we have a multiplication product here, and Sam is using division to find the unknown process, the unknown number. And the question is Sam's approach reasonable? So tell me if you think yes or no. And then explain, right? Because this question is a yes or no question. So tell me yes or no, and then give me a little bit of an explanation of what's an example of what you would write. Good, excellent, right? So our answer is definitely yes. And then the why is because these are opposite operations. That's a perfect response. Does anybody else have any other ideas of what we could write here? Oh, absolutely. I would say yes, because division is the opposite of multiplication. And both equations represent 63 being divided into 7 pieces. Something like that. So in general, what you want to show to get a full 2 out of 2 response is that you understand what they're testing. You understand that multiplication and division are inverses. And you have a complete and correct response. So you need this yes, and you need the explanation. Each one of those is worth 2 points. And an understanding that somehow these are inverses. So whether you actually say that they're inverse, or whether you say like 63 divided by 7 is 9, and 9 times 7 is 63, those are equivalent. You can say either of those things to show that they are opposite operations and that both are a valid way to solve the question. Both are going to give you equivalent. All right. Excellent, guys. So we're about 1/3 of the way through to our webinar. We're going to go ahead and move on to 4th grade. I'm going to scroll all the way to 4th grade math, and we'll do the same sort of approach for the next 45-ish minutes or so, maybe 40 minutes. We'll do multiple choice and then short answers, and then our last 30-40 minutes will be 5th grade. So if everybody needs a second to get up, to stretch, we're going to keep going. And I do want to say that for the students that, are in 4th grade, we just did 3rd grade, or 5th grade, we were going to do 4th grade, whatever it is, all of these have very similar concepts. So it's still very reasonable and useful for you guys to listen in and just to try to take what I'm saying, even if the question is easier, and learn how to apply and approach these types of questions. That's what's most important. Like, not even the questions themselves, but the application and the approach, and the ability to then later on take these concepts and move them to more difficult things, such as, the SHSAT for high school, or the LSAT for, middle school, or whatever other exams, Hunter exam, whatever other exams you guys may be preparing for. Okay, so everybody can do a quick little stretch, quick little wake up, quick little few jumping jacks, and we're going to keep going to the 4th grade math now. So just like before, we're going to start with multiple choice. That's what it starts with. And then we'll move on to the explanations portion. So this first question, we have Julia moves the arm of a spinner 1 degree at a time 45 times. How many total degrees does Julia move the arm of the spinner? So you see, we just went from 3rd grade to 4th grade and not much changed, right? So we don't have the keyword each there, but it's a very similar type of problem, right? one degree at a time, 45 times, right? We do this 45 times. So in total, we moved the arm of the spinner 45 degrees. So our first answer is B. This is just a simple product. It's a little teensy bit more difficult because you can see that they don't use the same keywords as they did for third grade, but still same exact concept, right? All it is a product question. And again, looking at the options, like A makes no sense, right? That's our nonsense answer that we can eliminate right away because just one time she moves at 1 degree, and they're asking us how many degrees is it after a total of 45 times. So no way that it can be only one. So we can eliminate that right away. Now, number 2, what does the word perpendicular mean? Perpendicular means they cross and they make a 90-degree angle. So all we have to do is find that, and that's right here. Choice C, we can just see that visually. How do I describe the relationship between these lines in choice D? They're not perpendicular, otherwise they would have been the answer to our question. But how do we describe them? What do those lines appear to be? So these lines appear to be parallel. So by definition, what parallel means is they appear like they will never intersect. They do not intersect. So if we imagine this can go on like forever, right? But it doesn't seem like they're ever going to intersect because they're perfectly parallel. And just for you guys to see, it doesn't only have to be these horizontal lines, right? You can have parallel lines in any plane. So you can have lines that look like this and they are also parallel. Or you can have lines that are perfectly vertical that are also parallel. So all of these are examples of parallel lines. And while we're reviewing this kind of vocabulary, I want you guys to tell me, how would I describe this angle here that I am shading in green? What adjective or what word can you guys think of to describe that angle? Absolutely, acute. So just to review, acute is an angle that is less than 90 degrees. So we can see that that angle is less than 90 degrees. And then just to fully review, how would we then describe this angle here that I'm now marking in blue? What's the word for this angle? Absolutely. This one is called obtuse, and then by definition, obtuse is greater than 90 degrees. So these are important, just little vocabulary words for you guys to be familiar with. Perpendicular, parallel, obtuse, acute, all fair game for them to use this language on this exam, and you guys need to know what it means. Okay, so moving on to the next page, we have the ground in a rectangular section of a park. So right away, I'm going to be visual, right? Rectangular section of a park. I have a rectangle, and then they start giving me information. Length is 24 and width is 12. So length is 24 and width is 12. And what do they want? They want the area. So what's our formula for area? So we're reviewing for like the third time today that area is just length times width. Now, this is a multiple choice question. So let's say I didn't want to multiply 24 by 12. What do you guys think the answer is just based on looking at this? Just based on estimation. Right? So let's estimate this to about 25, and let's estimate this to about 10, right? 25 times 10 is 250. So right away, these are all too little. I know this is going to be my answer, right? So I don't have to spend time doing it. On the test, you have plenty of time. So absolutely, you should multiply it out. But again, my goal is just to train your brain a little bit in the right direction. Just a little bit, that you don't always have to do all the math in this kind of multiple choice setting of an exam. If we do multiply it out just for practice, we have 2 times 4, which is 8. and 2 times 2 is 4, and 1 times 4 is 4, and 1 times 2 is 2, and we still end up with 288, which is our answer. Another thing that I usually teach my older kids that I prepare for, later on types of exams, is the unit rule, right? So as soon as I multiply 4 by 2 and 8, I know that my answer must end with an 8, right? Whatever all these other digits are, whatever they add up to, however that changes, I don't know, but I know that my last digit has to be an 8. So just by looking at 24 times 12, I know that I'm looking for an answer that ends in 8. And with estimation and that rule, you're basically, you know 100% that choice D is the answer, right? Even if they had another option that was 284 or 287, which is really, really close and you wouldn't be able to estimate it, I know that my answer has to end with an 8. So I know that's the answer for sure. I don't have to spend my time. But absolutely, this is how you would multiply it out if you wanted to. Okay, now this is asking us about the placement of a digit in a number. So the 6 in this question, where is it placed? Which place? So what options? Yeah, absolutely. This is in the thousands. Good. And how about the 6 in the next number? Where is this placed? So this one is placed in the tens. So how do I go from 10 to 1,000? What do I have to multiply by? How many zeros am I missing, right? So 1 0, 1 0, 2 zeros. So 2 zeros, 100. So for this question, for anybody that may be a little bit confused, let's just go the extra step and let's review placement of digits, right? So let's do up until a million, right? So we have 1, 2, 3, 4, 5, and 6. So this is called millions. What is this one called? This one is called 100,000. This one is called 10,000. This one is just called 1,000, right? 1,000. That's where that 6 was in the question that we just did. And then we have 100, we have 10, and we have 1. I usually don't see them go greater than a million for this test. So that's the notes that I wanted to give you and the review that I wanted to put on this page. This is the places that you guys should really know comfortably. All right, does anybody have any questions? All right, so moving on to the next page, we have what equation represents the statement below? And our statement is 48. So the way that I always translate my statements is I do it as I'm reading. So the number, it's written 48. So we just switch this to 48. Is a key word for equals, always. So 48 equals. At this point, we're able to eliminate A and B right off the bat. So 48 equals, we have 6 times as many as 8. So 6, and then times tells me multiplication. And then 8. And that's our answer, choice C. So a big thing to take away from this question is that is equals equals. Is means equals. In a word problem or in a word expression, is always, always means equals. Okay. Moving on to the next thing. So we can see like this is very similar to the third grade test, which showed us that question where it was showed us shaded rectangles and we had to represent a fraction. So how would we represent the first one as a fraction? So how many pieces are shaded out of a total of how many boxes? So in this first one, we have 3 pieces shaded out of a total of 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And how about in the second one? We have the same number of boxes, right? 1, 2, 3, 4, 5, 6, 7, 8. And in this case, 4 are shaded. And now they want sum. So again, sum means addition. Sum is a key word. It tells you to do the operation of addition. So we have to do 3 over 8 plus 4 over 8. Our denominators are the same, so that stays the same. All we have to do is add up the numerators. So 3 plus 4 gives me the final answer of 7/8. Be careful to read carefully because they can ask you for the difference of the fractions, and then that would be A, right? This is the difference. Or they can ask you for just the top fraction or just the second fraction, which is what 3/8 and 4/8 are. So the options that they put on this exam, they're curated, right? So they're all a potential answer. So you just have to make sure that you read carefully and that you're answering the question that they want you to answer. In this case, they wanted the sum, which is why we added up these operations, these fractions. Okay. Pushing along, we now have a line plot, and the line plot shows us the distances Mark ran on each of the 5 days last week, right? So 5 days, that's why we have 1, 2, 3, 4, 5 marks, because he ran for 5 days. Total number of miles. So this tells us that we have to add. So what am I adding? I'm adding 1 1/4 plus 2 plus 2, right? Be careful. Don't forget to count 2 twice because it seems like for 2 days he ran that same number. And then the next x is at 2 2/4. And then the last x is at 3. So who's going to add this up for me? How do I add up mixed numbers? Yeah, so let's add up all the constants first, all the whole numbers. So 1 plus 2 gives me 3, plus 2 gives me 5, plus 2 gives me 7, plus 3 gives me 10. So we have 10. So I know that it can't be this. I know it can't be that. And then what about the fractions? I have to add up 1/4 and 2/4. And what does that give me? Excellent, 3/4. So my final answer is 10 3/4. So do you guys know how to convert numbers? Like what if I got 10 5/4? How would I rewrite that? So if you ever have a fraction that's greater than 1, right, we can replace this as 10 plus 4 over 4 plus 1 over 4, right? I split that 5/4 into 4/4 and 1/4. And then 4 out of 4 is just 1, right? So 10 plus 1 plus 1/4. So this gets transferred into 11 1/4. So I just wanted to show you guys what we can do with a number that is, a mixed number that is greater. We can then convert that to 11 1/4. And how about converting these to improper fractions just for practice? So if I wanted to write this whole thing as a fraction, I could make it 10 times 4, which is 40, plus 3 is 43. So 43 over 4 would be the improper fraction. Right? Just to review some side things that are not necessarily relevant to this question, but could be tested. All right, so I'm going to clear that just so if you guys are reviewing the notes, it doesn't confuse you. But those are important concepts that I want you guys to consider as well. So mixed numbers and proper fractions. Okay, so this question is asking us about rounding. So it's saying that a number rounded to the nearest hundred, right? We talked about places. So this is our hundreds place. I'm circling it in all of our options. Is 3,700. Which number could not be the number before it was rounded? Or another way of asking this is which number does not round to 3,700? So what are the rules? How do we know whether to round up or to round down? Well, the rule is to go to the place next to it, right? So in this case, we're talking about rounding to hundreds. So you're going to go to the place that's right next to it, that's lower, to the tens place, and you're going to look at the number at the tens place, right? If the number at the tens place is less than 5, then round down. If the number at the tens place is 5 or greater, then we round up. So let's play this game, right? In this case, 4 is less than 5, so we're going to round down. So that means that's 3,700. 2 is less than 5, so we round down. That's 3,700. 5 is 5 or greater, so instead of 36, we round up to 3,700. And then finally, 1 is less than 5, so we round down, and this would stay as 3,600, not 3,700, so A is our answer. Does that make sense for everybody? Anybody have any questions? Okay, so we're gonna move on. We have which list shows only fractions less than 1/2. So we played this, I taught you guys this rule already, right? So the rule is when all the numerators are the same, right? Looking at choice A, all the numerators are the same. How do we know which fraction is bigger or smaller? So when numerators are the same, the higher the denominator equals smaller fraction, right? So here the denominator 3, 5, 8, all of those are greater than 2. That means all those fractions are smaller than 2. And that means we don't have to waste our time with any other of these options and figure out the more complicated fractions. We know automatically that our answer is A. And again, if you guys start sort of getting into the habit of memorizing your conversions and you know how to convert, fractions to decimals, this type of question again becomes a lot easier, right? So 1/2 we should all know is just 0.5. 1/3 we reviewed in the last section as 0.333. 1/5 you guys should learn is 0.2, and then finally 1/8 is 0.125. So we can see that all of these values are clearly less than 0.5. So you don't have to do that, but you could start memorizing them, which will help you later on. Or you could sort of figure out what those are numerically and calculate them by doing division, and then compare them as decimals. Another thing that can help you is they want fractions that are less than 1/2, right? And just looking at the options, like 2/4 is equal to 1/2 and 6/12 is equal to 1/2. So right away I can get rid of B and C because that does not make sense. And then looking at these fractions, like 7/10 is really easy to convert into a decimal, right? That's just 0.7. And you know that's greater than 0.5. Or you know that 5/6 is more than half because half is just 3/6, or 3/4 is more than half because half is just 2/4. So just based on process of elimination, you also have enough evidence to eliminate B, C, and D, and that way you're only left with one. All right, how are we going to tackle number 22? So number 22 wants the measure of this angle. So how would I do this? So truly the only way for you guys to get this answer in this case would be to measure the angle. And I think they provide you the instruments to do that. But I can tell you just looking at it that none of you guys listening to my webinar are going to go in there. And even if you didn't have the tool to measure it, there's no way that you're going to pick A or B, right? What kind of angle is this? We said the name earlier in our lesson on the first page of the 4th grade packet. How would we describe this angle? It's obtuse. Excellent. And that means that it's greater than 90, right? So there's no way I'm picking A. There's no way I'm picking B. And once you guys measure it, the correct answer is choice D, 161. And again, obtuse means greater than 90. Okay, so we have 3 pans of brownies are for sale. Each pan has 5 rows with 5 brownies in each row. Okay, so we have 3 pans, right? 1, 2, 3. And in each pan, we have 5 rows of 5 brownies. Right, so we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Right? And so in total on one pan, how many brownies do I have? 25, excellent, right? So 5 by 5 gives me 25. And I'm selling each brownie for $2. So each of these 25 brownies, I'm going to sell for $2. So I'm going to multiply that by $2. So how much money am I going to make if I sell all the brownies on just one pan? 50, right? So 25 times 2 is 50. But I've got 3 pans, right? 1, 2, and 3. So the last thing that I have to do is I have to multiply 50 by 3 to give me my total amount of profit that I'm going to make, which is 150. Okay, so for this question, they want you to know how many degrees is a full circle. So who knows how many degrees in one circle? 360, excellent. So now they want you to take 1/4 of that. So 1/4 of 360 is going to be how many degrees? Just 90, right? Because we're going to cut 360 into fourths and we're going to end up with 90 degrees. What if they asked you to just cut it in half? Half a complete circle. What would our answer be then? 180. Excellent. And just to review some vocab, right? When we do that, we create perpendicular lines, which makes sense because perpendicular by definition is 90 degrees. So when we cut a circle into fourths, we create perpendicular pieces and they're each 90 degrees. And then it also makes sense that half is 180 because if we add 90 and 90, right, we're going to get to 180 and that's half of a circle. So it makes sense in every direction. Okay, next question. We have what is the value of 7,839 times 9? So right away, what I see in this question, remember the unit rule I taught you guys? 9 by 9 is 81. Uh-oh, all my options end in 81. And all my options are pretty close together. So what they're telling me in this question is that I don't want you to estimate. I don't want you to use logic. This is a pure arithmetic question. This question was written to test whether or not I could carefully multiply this out, whether or not I can do arithmetic and not make a silly mistake. So in this question, all I would do is I would carefully multiply it out. So 7,839 times 9. We're going to follow our rules. 9 times 9 is 81. That's 1. I'm going to carry the 8. 9 times 3 is 27 plus 8 is 35. So 5 and 3. 9 times 8 is 72 plus 3, 5 and 7. And 9 times 7 is 63 plus 7 is 70. So we get our answer of 70,551. Next one, right triangle. So right triangle means we have a right angle. And right angle means we have 90-degree. So the only one that looks like there's a 90-degree angle in this case is this one, choice C. And here is where our 90-degree angle would be. What does choice D look like? What word would you use to describe choice D? Choice D to me looks like it's equilateral. Again, these aren't necessarily drawn to scale, and I could be off a little bit, but just to review that language, equilateral means that they're all equal, right? All sides are equal, all angles are equal. So that's what choice D looks like to me. It looks like an equilateral triangle. And how about choice A? How would we describe choice A? Choice A to me appears like it's isosceles. And in an isosceles triangle, two sides are equal and two angles are equal. So we have a right triangle, isosceles, and equilateral in this case. We've got 3 different vocab words that we can review with this question. All right, so we're gonna move on to session 2. Let's see, we'll start with the multiple choice and then maybe we'll do 1 page of multiple choice and then we'll do the same thing. We'll jump to the short answers and then we'll move on to 5th grade by 7 o'clock. All right, so we have Mr. Jonas ordered a pizza to take home. His children ate 4/8 of the pizza, and he himself ate 2/8 of the pizza, and the remaining pizza was saved for later. And the question is, which equation could be used to represent the whole pizza? Okay, so we have 4/8 and 2/8, right? So that has to be within our, so if we ate with 4/8, right? And then we ate another 2/8, right? That means we ate a total of 6/8 of the pizza. How much of the pizza is left? Yeah, right? 2/8. So that means that this is our missing piece to add to 1, right? So we need 4/8, 2/8, and 2/8, and the only choice that gives us that is choice C. Okay, so next question, we have Matt has 4 pens. Sue has 4 times as many pens as Matt. So how could I describe the number of pens Sue has? 4 times as many as Matt. So 4 times Matt, and Matt has 4 pens, so then I can replace this 4 with Matt. So 4 times 4. And then Chris has 2 times Sue. So this is Sue, right? So Chris is equals to 2 times Sue. Instead of Sue, I can replace it, right? So Chris is equal to 2 times 4 times 4. And the only option that tells me that is choice C. Good, so I feel like this one was a little bit challenging. Does anybody have any questions? Okay, let's do one last page and then we'll switch to the short answers. We have Lynn measured the height of a plant on Monday and then again on Friday. The diagram shows the plant's height. And the question is, how many inches did the plant grow? So how would we approach this one? So we would have to, spread this and see that we were at 2 and now we're at 3. So what is the difference? So pretty easy, right? All we have to do is subtract. 3 minus 2 is 1. Another way to do this is just say, well, how many inches do I have to go from 2 to 3? It's just 1. It's the same exact idea as subtracting. And the last one for us here today, before we move on to the short answers, we have Sam has 12 baseball cards, right? So Allie has 4 times as many as Sam. So again, 4 times Sam, but I know that Sam is 12. So Allie is 4 times 12. And then that's easy. That gives me my answer, choice D. And again, you don't have to think so hard here. The question tells you the operation. Times tells you that what I'm going to have to do is multiply. And there's only one choice that has that operation. It's choice D. So you don't even have to think about what the answer is. Just seeing multiplication there makes you confirm that the way to do it, the way to write the equation is choice D. All right, so with that being said, we're going to skip these next few pages and we're going to run to the short answer questions. We're going to do these 2 pages of short answers. Okay, so this first short answer, we have the relationship between tickets earned and points earned in a game is described below. So 1 ticket for every 9 points, 2 tickets for every 18, 3 tickets for every 27. And the question is, how many tickets when 54 points are earned? So I want you guys to try this. Try to realize what is the pattern that they're showing us. Yeah, add 9, right? So we have 1 is 9. We've got 2 is 18. 3 is 27. So on my left side of my table, I'm going up by 1. And on the right side of my table, I'm going up by 9. That's the pattern. Plus 1, plus 9, right? So what's going to happen when I get to 4? 36, good. And then what's going to happen when I get to 5? 45. And then when I get to 6, I'm going to get to what they want, which is 54. So 6 tickets are going to be earned for 54 points. So our answer is 6 tickets. So just drawing out a table like this alone would be sufficient to show your work if you show like the +1 and the +9 like we did on the sides. Another pattern that you guys could have noticed is to get from 1 to 9, we have to multiply by 9, right? To go from 2 to 18, we multiply by 9. So then, like we were saying before, multiplication, division are opposites, right? So what you could do is you could say 54 divided by 9 is going to be 6. That would also be sufficient to show your work. So any way would be sufficient to show your work. You guys would get full credit. Okay, so now let's approach number 40. Number 40, we have an obtuse angle, 143 degrees. And then they use this new vocabulary to create a straight angle. What does a straight angle mean? And how much does it measure? Excellent, right? So a straight angle is a straight line, like I'm filling in here. Well, it doesn't look super straight, but let's pretend that it's straight. Maybe that's a little bit better. And by definition, a straight angle equals 180 degrees. That's a definition that you guys must memorize. So this whole thing equals 180. So to get that missing piece, what operation do I have to do? Subtraction, excellent. So I have to do 180 minus 143, which is going to be 37 degrees, and that is our answer. And again, that is sufficient to show your work, just to say 180 minus. All right, guys, excellent work. Let's move on to the explanation questions now. So we have dotted lines were added to the two figures shown above to represent lines of symmetry. Which figure shows only correct lines of symmetry, and explain why? So I'm going to give you guys a few minutes to think about it. Again, just like we talked about in the third grade, to get full points here, 2 out of 2, you need to answer their question. So here it's either figure A or figure B. And then you have to have an explanation as to why that demonstrates that you understand the concepts they're testing here, which in this case is geometry and symmetry. So figure out if your answer is A or B, and then figure out what your reasoning is. And then once 1 or 2 people put it in the chat, in a minute or two, we will review together. Excellent. Yep, people are getting it in the chat. So the answer here is figure B. Good. Good. So figure B, and then you guys have to say something that shows that you understand what does symmetry mean, right? Symmetry means that if I fold it, it's going to be perfectly aligned, right? They'll fit onto each other. So you have to give the answer of figure B shows correct lines of symmetry. And then you explain it because if folded against the dotted lines, the figure will align perfectly. Right? Something like that. Or you could say because if A is folded against if A is folded in half, the two parts will not coincide exactly. Right? So either you can explain why A is not symmetrical or explain why B is symmetrical. But either way, you have to show that you understand what it means to be symmetrical. So some explanation of nothing sticking out when you fold it is necessary, whichever way you phrase that. So in this case, you have to answer the question and show that you understand what symmetry means. That's the goal of getting full points here. Okay. So now we're going to move on to question number 42. So 42 says we have the population of city A is 84,206. Population of city B is expressed by this expression. Write a number sentence to compare the populations of city A and city B and explain how you know your answer is correct. Okay, so how would we add up this expression? So first, I want you guys to tell me both of these expressions in numbers, right? Type it out into the chat because they gave them to us both in different circumstances, right? So 84,000, so 84,206. And now we add this up. 80,000 plus 4,000 is 84,000. And then we have 200 plus 10 plus 6. So now we have both of those values, and now,
210.
and now, sorry, my Siri just went off. And now which one is larger, which one is smaller? Right? That one is which one? Larger, right? So this is our symbol for larger. And now in words, how would you guys explain that? Right, 16 is more than 6. Great. Or you can say that 1 in the tens, all the digits are the same, except in the tens place, 1 is greater than 0, right? So any explanation that shows that you understand how to compare numbers. Does that make sense? So you could say, I know my answer is correct because the numbers have the same digits in all places except the tens place, and I know 1 is bigger than 0. Excellent. All right, guys, so we got through the 4th grade section. So again, everybody can take a break for a second, do a stretch, do some jumping jacks, wake up, take a sip of water. And for the last stretch of our webinar, for the last half an hour or so, we're going to do the same exact thing for the 5th grade session. So we will get through the multiple choice. And then in the last 10 minutes or so, we'll move on to the short answers and work through those explanations. Okay? All right. Are you guys ready? Okay, so let's go ahead and tackle 5th grade. So we have our very first one, which is saying Jill has 4 $1 bills, 3 quarters, 4 dimes, and 3 pennies. Mark has 3 $1 bills, 4 dimes, and 2 pennies. And they want us to figure out the difference in the amount of money Jill and Mark have. So first, let's do Jill. How much money does Jill have? So 4 $1 bills is how much money? Four $1 bills is $4. And then how much is 3 quarters? Each quarter is 25 cents, right? So 3 by 25 is going to give me 75 cents. And how much is each dime? Each dime is 10 cents. So 4 dimes is going to be 40 cents. And then finally, 3 pennies is 3 times just 1 cent. So that's going to be 3 cents. So now we add this all up, right? $4, 75 cents, 40 cents, and 3 cents. This is going to be 8, 11. So that is $5.18 for Jill. And we're going to do the same thing for Mark. So Mark has 3 $1 bills. So $1 times 3 is going to be $3. And he has 4 dimes. So 10 cents times 4 is going to be 40 cents. And then he's got 2 pennies. So 1 penny, 1 cent times 2 is going to be 2 cents. So this is going to add up to $3.42. So the last step is subtracting them. So again, looking quickly at this, which one is definitely not the answer? Which one is our nonsense answers? We're trying to subtract them, right? So we're going to have a number that's 5, approximately 5 minus 3, right? So approximately 2. So there's no way that it can be C. There's no way that it can be D, right? They want the difference. So our word problem is giving us the operation that we need to do. We need to do subtraction, right? So definitely not C and D. Those are going to be too big. And when we do $5.18 minus $3.42, you guys can use the unit rule here, right? So as soon as we start subtracting, I know that I'm looking for an answer that ends in 6. So I know my answer is going to be B. And then, of course, you can finish subtraction just to get your full answer, which is $1.76. Okay, moving on to number 2, we have a simple addition of mixed numbers, but what's the difficult part is that our fractions don't have the same denominator. So how do I tackle this? How do we add up fractions that do not have the same denominator? What do we need to do? So what we need to do is we need to make them have the same denominator, right? So we need common denominator. So what's a common denominator in 5 and 3? What can we use? So if you look at the answers, they're kind of giving it away, right? We've got 3 answers that have this denominator of 15. And it's not a coincidence that 5 and 3 fit into 15, right? So that's kind of a hint. Whenever you're stuck, you can look to the answers and they can kind of help steer you in the right direction. So 3/5, I want this denominator to be 15. So I have to multiply both the top and the bottom by a number that makes my denominator 15. So when I multiply 5 by 3, I get 15. But I can't just multiply the bottom and not touch the top, because the only reason this rule makes sense is because I multiply the top and the bottom by the same thing. And in that way, I'm not changing the value of my fraction. Because when you multiply 3 over 3, 4 over 4, whatever it may be, you're just multiplying by 1. So instead of 3/5, this switches to 9/15. And then we're going to do the same thing to the 2/3. So then we're going to have 2/3. Again, I have to multiply by 5 on the bottom to get 15, which means that I'm going to do the same thing to my numerator, 5 over 5. This is going to give me 10/15. So now I have 6 and 9/15 plus 3 and 10/15. So 6 plus 3 will give me 9. And what's 9 and 10? What is that going to give me? That will give me 19 out of 15. And now I have a little bit of a problem because none of my answers are 9 and 19th out of 15. So I have to do a little bit more work because this is greater than 1, right? So now I have to work backwards. So I split this into 9 and 15 over 15 plus 4 over 15, right? I split this because 15 plus 4 gives me back to 19. And 15 over 15 is just 1. So I have 9 plus 1 plus 4 over 15th. So this simplifies to 10 and 4/15. So this one was a little bit involved, but this is a very, very common thing that they test, common denominator. So again, just to review, we switch each fraction into having a common denominator. Then we do our operation, which in this case is just adding. And then finally, you have to make the answer simplified. So our mixed number over here, this was an improper fraction. It was too big. So we had to simplify it down to 10 and 4/15, which is our final answer. Now, the next question says, which two-dimensional figure is always a regular quadrilateral? So always is a strong word in a question because almost nothing is always. So that's one thing to consider here. And the second thing to consider is this word regular. So who knows what it means to say that a shape is regular? What does the word regular mean? So the word regular is an important vocabulary word for you guys to have for your exam. The word regular means equal angles and equal sides. That means all the angles are equal and all the sides are equal. So now that we know that definition, in which shape are all the sides and all the angles always, always, always equal? Great, right? In a square, right? By definition, a square has all equal angles and sides, right? By definition. A rhombus, a polygon, this is way too broad, right? So it's possible, but a square is always, right? The key word here is always. A polygon, it's possible that a polygon is a regular quadrilateral, but it's not always a regular quadrilateral. But a square is always a regular quadrilateral because by definition, all the sides and angles are equal. Okay, moving on to the next page. We have Janelle makes fruit punch by mixing these ingredients. We've got 5 pints, 6 cups, and 8 cups. And the question is, how many quarts of fruit punch does Janelle make? So how do I tackle this? So what I learned back in the day that I always love teaching my kids is this diagram of the following. So we have a G, that's our gallon. And in a gallon, we have 4 quarts. And in each quart, we've got 2 pints. And then in each pint, we've got 2 cups. So I love this picture because it's fun to draw, it's visual, and it tells you all the conversions that you need to know that have to do with these. So we've got 5 pints of orange juice. So in each pint, right, 1 pint is equal to 2 cups, right, according to our little figure that we just drew. So if we have 5 pints of orange juice, how many cups of orange juice is that? Right? We multiply by 5, right? I went by 5, so we're going to have by 5. So we have 10 cups. So in total, we've got 10 cups of orange juice, 6 cups of grape juice, and 8 cups of apple juice. So in total, how many cups do I have? I got 10 plus 6 is 16, and then plus 8, I've got a total of 24 cups. But be careful, right? We're not going to pick C because the question is quarts. So then we can see that in 1 quart, I've got 4 cups. So 1 quart is 4 cups. And the question is, well, 24 cups is how many quarts? So what is the relationship that you guys see? How do I go from 4 to 24? What operation do I have to do? I have to multiply by 4, right? So to go and get this unknown, I'm going to do the same thing. Sorry, I have to multiply by 6, I meant. I'm going to multiply by 6, and that tells me that 24 cups is 6 quarts. And be really careful and don't pick 24 because that was kind of the trick answer here. Big takeaways is this nice picture that helps us remember all the conversions, and then just playing around with these conversions and how we go back and forth. Next, we've got Sarah, who's building a birdhouse. She cuts a 6-foot long board into sections that are each 1/3 foot long, right? So imagine we've got 6 feet. We've got 1, 2, 3, 4, 5, 6. And we're cutting each of these 1-foot pieces into thirds, right? So we cut this into thirds, and we cut this one into thirds, and we cut this one into third, and this one into third, and this one into third, and this one into third. And the question is, well, how many pieces do we have in total? So if you add up all these pieces, you'll see that our answer is 18. So again, you can do this visually. You can count all the pieces, or you can see that, okay, I cut it into 6 1-foot pieces, and then each one of those into 3. 6 times 3 gives me 18. Or you can try to do this mathematically, algebraically. You could say 6 divided by 1/3. And remember, when you divide by a fraction, you multiply by its reciprocal. So we change the sign, and then we flip. Instead of 1/3, we have 3/1, and we still end up with 18. So you can do it visually, you can try to think it through and do it logically, or you can do it arithmetically. Any way that you do it will get you to the same answer. And again, I like showing the different techniques because in the options where you can show your work, any one of these ways, any one of these techniques will work. So wherever your brain gravitates to, wherever you're comfortable, whatever you think of first is completely appropriate to do on the exam. All right, let's get through a few more and then we'll go to the short answers. So this sign, just to review, means what? Does it mean less than or greater than or what? So this sign means less than, right? So just to review, we have greater than, we have less than. And what do these signs mean? What if they're underlined? What if there's a line underneath? What does that mean? That means greater than or equal to. And then finally, we have less than or equal to. So what is less than 0.6? Which option is less than 0.6? A won't work because this is equal. 0.7 is greater than. 0.64 is greater. And the only option that's less than is 0.59. And again, you compare the right places, right? So this is our 10th place, and we're going to compare it to our 10th place and see that 5 is less than 6. So that's how we know that 0.59 is less than 0.6. Next one, number 14, is a conversion question. So we have 1 hour and 34 minutes, and they want to convert this to minutes. So how many minutes are in an hour? 1 hour is how many minutes? This is a conversion that is not given to you. You just have to memorize it. 1 hour is 60 minutes. So we can replace the 60 minutes, right? So instead of 1 hour, it's 60 minutes plus the other 34 minutes to give you that final answer of 94 minutes, choice C. And that brings me to number 15, which is our first long division question. So how are we going to tackle this? So 2,158 divided by 26. So 21 is too small. So the first thing that I'm thinking is how many times does 26 go into 215? So again, I want to teach you guys to use the answer choices to your advantage, right? So you can see that every answer choice begins with an 8. Right? So I'm not going to try 6. I'm not going to try 7. I'm not going to try 4. I'm going to try 8 because that makes sense because all my answers start with 8. So almost automatically, I know kind of that it fits 8 times. Does that make sense to everybody? So I'm going to put an 8 up here. And then on the side, we're going to do 26 times 8. We're going to get 8, 4, 208. So then I'm then going to subtract 208. And now we subtract, right? This becomes 15, this becomes 0. 15 minus 8 is 7. Everything else cancels out. And then we drop our 8. And now the question is, well, how many times does 26 fit into 78? So now we use a little bit of logic, right? So 20 goes into 63 times, and 26 is a little bit bigger, and 78 is a little bit bigger. So I'm going to guess 3. And then we just double check. We say 26 times 3, 18, 7 minus 78, 0. Perfect. That's my answer. No remainder. It's 83. Again, you can use the unit digit rule backwards, right? So 26 times 83 has to equal 2158. And if you look at these last digits, right, 18, I'm going to drop the 8, the 1 will hold. So I know that my answer has to end with 8. So I know that 6 times 3 is valid for my answer to end with 8. And none of the other options would make sense, right? Because 6 times 0, my answer would end in 0, but I need an 8. 6 times 6, my answer would end in 6, but I need an 8. 6 times 9, my answer would end in 4, but I need an 8. So again, this is testing long division, but I'm weaving in these other important concepts like the unit digit, like estimation, to start preparing your brains for something greater, something more difficult. All right, guys, let's jump to the short answers just to make sure that we have time to cover everything. So we'll do these 2 pages of short answers and then we'll finish up our webinar. So we have Callie works at a pet store. Part of her job is to add the correct amount of water conditioner to each fish tank. The list below provides information about the number of fish tanks and the amount of water conditioner she uses. So 12 tanks need conditioner. Each tank has 20 quarts of water, and for each 10 gallons of water, she uses 1 teaspoon of water conditioner. Okay, so we've got a lot going on here, right? So first, let's think about how many total quarts of water she needs, right? To fill up all the fish tanks. So it's 12 fish tanks times 20 quarts. So that is 240 quarts. Then we can see that we need a conversion, right? We're switching from gallons to quarts, and the relationship between the conditioner is in gallons. So now I have to do a conversion from gallons to quarts. So this gives us a good excuse to review and redraw our chart. So if you remember from our chart, how many quarts are in 1 gallon? 4. Excellent, right? So 1 gallon is 4 quarts. But we're interested in knowing, well, how many gallons are in 240 quarts? So again, how do I go from 4 to 240? I have to multiply by 60. So I'm going to do the same thing on the other side, right? And that means that 240 quarts are 60 gallons. So now the last step of this is for 10 gallons, that's 1 teaspoon. So I need 60 gallons. And that's going to be how many teaspoons? How do I do that? Again, just like before, right? To go from 10 to 60, that's times 6. And do the same thing on this side. And my final answer is going to be 6 teaspoons. Does that make sense to everybody? This is a multi-step question, right? So we use some of the concepts that we learned in the 3rd and 4th grade test where we multiply, we use a product, right, to get the full 240 quarts. Then we do a conversion. So we review our conversions and we review that in 1 gallon, there are 4 quarts. And we figure out that in 240 quarts, that is 60 gallons. And then finally, we convert 10 gallons is 1 teaspoon, 60 gallons will then be 6 teaspoons. So multi-step problem. And to show your work, you do everything that we did, right? You show 12 times 20, you show your conversion just like we did up here and down there. Now, question number 2. Equilateral triangle. So we reviewed that language today, right? So equilateral triangle means that all the sides are equal. So we've got 3 equal sides, and they're telling us that they all add up to 1/8. So side plus side plus side is equal to 1/8. So 3 sides are 1/8. How do I figure out what one side is? So if I was dividing a slice of pizza into 3, I would do 1 divided by 3. But in this case, I'm dividing 1/8 into 3. So I'm going to do 1/8 divided by 3. And again, the rule when you're working with fractions and when you're dividing, we have to do keep, change, and then flip. So we're going to keep, right? I'm dropping it down. I'm keeping it. I'm not changing it. We're going to flip. So we're going to change. I mean, instead of the division, we have multiplication. And then this one, we're going to flip. So instead of 3, we've got 1/3. So that is going to be 1 out of 24. Each side is going to be 1 out of 24. And if you double check, right, if each side is 1 out of 24, 1 out of 24, 1 out of 24, and we add that up, we have 1 out of 24 plus 1 out of 24 plus 1 out of 24. That adds up to 3 out of 24, which is just 1 out of 8. So we can work backwards to double check our answer. All right, does anybody have any questions on anything so far? So we're going to do one last question with an explanation, and that'll be the end of our webinar today. So we have this number, 714.438. It says, how does the value to the left of the decimal point, so I'm going to highlight that one in yellow, to the left of the decimal point, compare to the value of the digit 4 to the right of the decimal point? So I want you guys to think about this one. How do those numbers compare? So we went over values in a normal number, right? We said this is 100, this is 10, and this is 1, right? So we know that this 4 is which place? So that 4 is in the ones place, right? We know that's in the ones place. So this 4 is in the ones place. Now, what happens after the decimal place? Everything kind of gets mirrored. So this becomes the tenths place. This becomes the hundredths place. And this becomes the thousandths place, right? We add the TH. So obviously everything after the decimal place is smaller. So, and the difference in each of these places is by a factor of 10. So to go from 1 to 10 is times 10. To go from 0.1 to 1 is times 10. To go from 0.01 to 0.1 is times 10. So to compare their values, we could say that the 4 to the left of the decimal place is in the ones. The 4 to the right is in the tenths. The left, oops, 4 is 10 times the right 4, something like that. So you have to answer their question, right? They said compare the value. So you have to say that one is bigger than the other or one is 10 times as big. You answer that question and then you explain your understanding of the concepts, which in this case is different placements and how those compare to each other. Okay, so with that, that ends our webinar. I want to wish everybody good luck for tomorrow. You guys are more than well prepared. Thank you so much for spending your Monday evening with me and listening in. And if anybody has any questions at all, I can stay back a few minutes. And if not, you guys are all free to go. Have an excellent, excellent night and best of luck tomorrow on your exam. Thank you guys. Good night.